Hello everyone, I'm Tommaso Minuti, a researcher of the Robotic Institute of Scuola Superiore Sant of Pisa, and together with Professor Leonardo Ricotti, Andrea Mannini, Paolo Cigni with his staff, Stefano Rapetti and Samuele Melotto, we have developed a retrospective model that evaluates the incidence of various risk factors to prevent the lower limb injuries in elite soccer players. One of the themes of great interest in sport is the prevention of injuries. Especially in soccer, a lot of research efforts have been made to define which injuries occur more frequently and what are the risk factors that determine them. Lower limb damages are the most frequent one, especially muscle strain or tear of knee flexors and extensors, together with anterior cruciate ligament ruptures or sprains. In this study, we try to identify the role of muscle strength as possible risk factor for injuries. In particular, we propose a different approach compared to isokinetic dynamometers that perform isokinetic strength measurements in a sitting position, showing up to now conflicting results as possible risk factor for injuries. This innovative exoskeleton was developed to measure the maximal contraction force of knee flexors and extensors in isometric condition and keeping a standing position. This exoskeleton is composed by some support for trunk, knee and ankle to ensure more comfort during the test, and it assembles two load cells above the knee to measure the strength of the hip muscles and other two load cells above the ankle to measure the strength of knee muscles. The first step was finding the optimal angle for hip and knee at which knee flexor and extensors perform a maximal contraction. Recording the signal at different angles, we found that the hip and knee must be inclined, or respectively 30 degrees and 30 degrees for flexor test, while 20 degrees and 80 degrees for the extensor test. The subject was positioned in the exoskeleton with a standard procedure which favors the same positioning of the same subject at each repetition of the test. The reliability of the device has been evaluated with a test-retest analysis measuring the same variable over different time points. The interclass correlation values resulted either than 0.90 and most of them either than 0.95, showing an excellent reliability. Then, this isometric test was carried out on 107 professional soccer players playing in Italian and English top leagues. The test was repeated 3 times for each season, approximately every 3 months. Then the strength values and muscle imbalance indices was recorded, as well as the injuries occurred during 2 years of observation. A retrospective analysis was carried out on the acquired data to evaluate if there were any variables associated with injuries. A logistic regression shows that the selective variable included in the model classified accurately the 98.6% of non-injured and the 50% of injured subjects. This demonstrates the association between the measuring force parameters and the injury class recorded. Survival analysis show the average injury time of players considered at risk of injury in red line compared to those not at risk in green line. It proves that on average, players showing an imbalance in the strength between the flexor of the two limbs injury earlier. Finally, we built ROC curves to obtain the alarm cutoffs by means of which an athlete can be considered at risk of injury. This would constitute a practical tool that could be useful for coaches and trainers of soccer teams. In conclusion, our research introduced an innovative method to measure the isometric strength of the lower limbs and demonstrated its reliability and its usefulness in the study of injuries. I hope that our work raised your interest. You can contact me on this email in the case you need additional information, and thank you for your attention.